Hello and welcome everybody to this beautiful orbital sunrise around Drew, which is the home planet of the game SimpleRockets 2. This is going to be a little tutorial about Orbital Rendezvous and docking, because as many players have figured out, this is a pretty awesome game, but after having done the basic stuff like launched some satellites into orbit, maybe landed on the moon and visited some other planets, you slowly start to run out of things to do. So I think that learning how to rendezvous and dock is actually a great experience and a great way to enhance your possibilities in the game. Maybe build space stations, as I've done here with the model of the International Space Station, for example. So first of all, this is not a beginner's tutorial. When you watch this video and when you start to try to do some experiments and try to learn how to dock, you should already be able to build a rocket, build a spacecraft, launch it into orbit. You should already know a little bit about orbital mechanics. For example, you should know the relationship between orbital speed and altitude, that lower orbits are faster and higher orbits are slower. You should be able to maneuver between different orbits. For example, you should be able to raise your apogee and change from a lower to a higher circular orbit and these things. And once you know that, it's a good situation for you to actually start some advanced stuff like rendezvous and docking. So let's go ahead and first build a vehicle and then launch it and go through the process of how to dock something to the space station. Alright, so here we are in the vehicle builder, and I've got a Falcon 9 model here which I've made. It has 9 first stage engines, it has some landing legs, but we're not going to use them today. We're just going to use the booster to go into orbit and not land it. On top of that, we have a second stage with 1 engine, and on top of the second stage we actually have a payload fairing, which is currently empty because we want to build a spacecraft which we launch into orbit using that vehicle. So the spacecraft we're going to build for docking is relatively simple. First thing we need is a command pod. Let me put that up here and scale it a little bit just to match the size of the Falcon 9. Alright, then of course on top of the command pod we need a docking port, because that's the entire point of the thing. Let's also make that a little bit bigger just to match it. The size of the docking port is not important, but it looks nicer that way. Okay, then what else do we need? We need a bit of maneuvering and firing stuff. So let's put a fuel tank on, but only a small one. Actually, we want 2 fuel tanks for this. One of them should be holding monopropellant, which we're going to use for the RCS, the reaction control system. And the second fuel tank, I can just right click and copy that, should hold a little bit of Kerolox, which is the standard jet fuel, standard rocket fuel. So now let's add an engine so that we can actually do some maneuvering, some changes in our orbit. And now let's add some RCS. So for the RCS, you see we have these parts here, these little RCS nozzles. So if we would just attach them sideways onto the fuel tank, for example, of course they would kind of work, but they would not be able to rotate the vehicle in any way. They would only be able to push it sideways, but not maneuver it along all axes we want. But for docking, of course, we need all degrees of freedom which we can possibly get. So here's a little trick on how to actually achieve that and properly install the RCS. And this is how it works. We actually take a block, just a simple block, attach it to the side of the fuel tank, and then on that block we actually install the RCS nozzles on the side, and that way of course we have all possible degrees of freedom. We can fire sideways to the front and to the back, and now we do that 4 times. Oops, I didn't want to do that. Undo. Yeah, we do that 4 times on 4 sides of the vehicle, so that everything is symmetric. If you look at the Apollo spacecraft, for example, it was very similar. It also had 4 groups of 4 RCS thrusters each on the side of the Apollo spacecraft in order to achieve the exact same thing, in order to have all rotation and translation degrees of freedom available. So this is a good way to do it. It takes a while to set up all 16, but let me just finish that real quick. Alright, here we are. So our spacecraft is basically already finished, but there's one thing I want to do which helps a lot in the docking process, and this is a good trick. So I want to set this command pod as the primary one by clicking set primary here, and then I can actually activate the pilot here to show the orientation of the pilot. And now I know where the up direction is, and also down and left and right. So the head of the pilot is pointing up, so this is the up side. And I actually want to mark this one to know when in orbit and when doing maneuvers, I want to know where the up direction is. So what I want to do is I'm going to paint this one, and let's for example paint this one black, because space is up and space is black, and maybe let's paint the opposite one green, because the Earth is green. And so we know that this is the side which is down for the vehicle. So now if I use my maneuvering thrusters using the A, S, D and W keys and the EQ keys for up and down, I will actually know which key corresponds to which direction in flight, because if I wouldn't have these markings, I would not know what happens if I press A or D or something like that. So we'll see later that this is a great advantage. Okay, so let's mate the vehicle onto the rocket. I think I have to make the payload adapter a little bit longer. Here we go. So let's, oops, I didn't want to do that. Yeah, let's mount the vehicle onto the rocket. This is a bit annoying sometimes, but I know that this is difficult. Okay, so here we go. And yeah, before we launch, let's quickly check our staging. We have 9 first stage engines, 1 interstage. Then we have 1 second stage engine. Then we have the fairing base, interstage, then the Pixie engine. Yeah, that looks very good. Staging is okay. So yeah, let's go ahead and launch it. Alright, so here we are at the launch pad, and if we press the M key and look at the map of the planet, we can see that it's not a very good idea to launch right now, because the space station is in this orbit, and we are not aligned with that orbit currently. So we have to wait until the planet actually rotates under the orbit of the space station, and that's what we can do using a time warp. Just go forward a little bit in time, and we can see that there is some point in time, which is right now, where our launch pad is actually aligned with the plane of the orbit. So now we could actually launch. And if we look at the dynamics, we can see that the space station is passing our launch pad towards the southeast, so we would also have to launch to the southeast to hit the same orbit in the same direction as we want. But we kind of missed that launch window right now, but it's a good thing that there's 2 launch windows per day to hit any orbit, because if we wait half a day, then of course the planet will rotate so that the launch pad again passes under the target orbit. So this is the case right now. It's a little bit early, but I think that's okay. Maybe let's wait a little bit longer. Now is a good time to launch, and we can see that right now the space station would pass towards the northeast. Not the southeast as before during the other side, during the other launch window. So you have to actually take care of in what direction you actually have to launch in order to hit the same orbit, depending on the time of day. So let's hit an initial heading of, let's say, 30 degrees, and let's actually launch this. Alright, so our first stage engine has almost burnt out. So right now we have Nico. Let's drop the first stage and ignite the second stage. And also we can look at the air density here. It's decreasing towards 3 grams per cubic meter. So let's also drop the payload fairings. There's no drag anymore. And we can actually continue with the second stage and the spacecraft to orbit. So what we can see here is that we have not perfectly hit the correct alignment with our target orbit, but that's not important. We can do some small adjustments later on. It's just that we are not able to do like huge adjustments to launch at the very wrong direction or at the wrong time of day. But if you get it roughly right to a couple of degrees, you're probably fine. So let's wait until we hit 200 kilometer apogee, because we want to hit a 200 by 200 kilometer target orbit just for parking. It's actually a parking orbit, so that we can make our adjustments and then plan our rendezvous from that on. But let's first get into some 200 kilometer orbit to do that. Alright, so our apogee is now at 200 kilometers. So let's plan a burn here. I clicked on the apogee and I use the burn gizmo now. I can actually make it a bit more sensitive, and I can use it to pull it forward and plan a circularization burn, which actually brings us into orbit. And we want to hit a circular orbit because this is really important. If you want to do some successful rendezvous and docking, it's much easier to do it using a circular parking orbit and also a circular target orbit. If they're not circular, it's a lot harder. So I actually recommend to use circular orbits for everything related to docking whenever possible. It will make your life a lot easier. So let me make some adjustments in order to have 200 by 200 kilometers, and we can see that it's actually looking pretty good. 201, 199. Let's take that as it is, and let's actually execute that burn automatically. We can click this and then time warp to the burn, and then make the vehicle automatically do this. There we go. Alright, so our second stage has successfully inserted us into our parking orbit. We can check we have 205 by 195 kilometers, so it's not perfectly circular, but close enough. As I said, it's very good to have a circular parking orbit and a circular target orbit also. So now we have plenty of time because we are in orbit. Nothing bad can happen. We can just wait for as long as we want, basically. But we have some stuff to do. You can see here that my current parking orbit, which I've injected us in, and the orbit of the space station, which is out here, are not perfectly aligned yet. So we still have some angle between them, and we don't want that. So let's click on the space station and actually look at the orbit details in this window here. And what we can see is that there's two angles here. It's 52.15 degrees of inclination and 142.06 degrees of right ascension. So what does this mean? Inclination means it's the angle with respect to the equator, and right ascension is the angle with respect to the poles. That's a simplified way to say it, but it's actually a pretty good fit. So we want to have both of those right. And when you click on our own orbit, we can see that we have 55.89 degrees of inclination, 142.10 degrees of right ascension. So we have to mainly correct only our inclination, because our right ascension is already pretty good. That's because we launched at the exact time we have to, so the right ascension is right, but we did not launch into the correct direction, in the correct azimuth. So that's why our inclination is a bit off. So the rule of thumb here is, if you want to change your inclination, you have to actually do that when you pass the equator. And if you want to change your right ascension, you want to do that when you're close to the poles. We want to change our inclination, so let's see where the this is about where the equator is. So next time we pass over the equator will be somewhere here, and you can see that this is also in this case, because only the inclination is off, where our two orbits kind of intersect. So I want to click that point, and then I want to drag and plan a maneuver where I burn perpendicular to my orbit plane alignment. So normally I would burn prograde or retrograde, but right now I want to burn perpendicular. And you can see here now that my orbits actually start to align a little bit better, and I can maybe make my gizmo a little bit less sensitive, and then I can actually, I want to hit an inclination of 52.15 degrees, because that's what the space station has. Here we go, 52.15, and at the same time we want to hit a right ascension of 142.06 degrees. That's what the space station has. So what we can do is we can pull that burn gizmo a little bit and pull it to the correct point where we have actually the right angles here. It takes a bit of practice to select the correct things to do here, but you'll figure it out. It's really just geometry, how to change that. And the rule of thumb is really, if you want to change inclination, do that by burning when you cross the equator. And if you want to change your right ascension, do that by burning in the same way when you pass close to the poles. So that's what you should do. So let's fast forward to that burn, and it will automatically execute. And yeah, now we can see the spacecraft has aligned itself perpendicular to its actual axis, and it's only a couple seconds of burn, but it still costs quite some delta V. So if it were a major correction, we would maybe not be able to afford to do it. And now we have cut off, and the angles are pretty good. We are 0.01 degrees off in both parameters, so that's really good. So we should be less than 0.1 degrees of tolerance. So we actually hit it pretty well right now. I would accept that. So this is good. Let's align ourselves prograde again. And now that we have hit our correct parking orbit, which is perfectly aligned with our target orbit, you can see that the two orbits are in one plane perfectly, and that's what we want to do. We can actually get rid of our second stage, because it's only really ballast at this point, because now the finer adjustments start, and we want to use our Pixie engine for that, and maybe not use the big second stage. All right. So if we look at the map, we can see that we are here in this orbit, and the space station is here. So if we warp time a little bit forward, we can actually see that what happens is that as we are lower than the space station is about in a 400 kilometer orbit, circular, and we are in a 200 kilometer circular orbit. So that means we are moving faster around the planet than the space station is. And this is a good thing, because of course right now, if we would just raise our apogee towards the space station's apogee, then we would probably not hit the orbit of the space station at the same point in that orbit where the station is. So we have to wait until we move in a little bit closer to the station until we can actually make that alignment. And that's a good thing. What we can do, and that's pretty nice, we can actually mark the space station as a target, and then we can look a bit into the future in how close will we get to the station in the next orbit. And it'll tell you it's like 1700, 1800 kilometers, so it's still very far apart. But you see that we are closing in, because the beginning of this orbit is 2500 kilometers, and at the end of this orbit it's only 1400. So we are gaining more than 1000 kilometers per orbit on the space station. We are closing in slowly. So let's wait a little bit until we've actually closed in a little bit more. One more orbit. And now you see that we would actually at some point pass the space station. And of course we don't want to do this, because then we would be in front of the space station. That would also not be good. We neither want to be behind nor in front. We want to just hit the point where the space station is. So let's make a rough guess, and let's say maybe here we can plan another burn. And what would that burn do? It would raise our apogee by burning prograde towards 400 kilometers, which is actually where the space station is. So now we have hit 400 kilometers of apogee, so this would be our transfer orbit, and we can see now with this planning tool here that our closest approach would be around 320 kilometers. So it's still not good. We would still be behind the space station. So we have to do that burn not at that point, but a little bit later. And I can actually now push my my burn gizmo, my burn planning tool here towards around the orbit a little bit, and I can push it until it actually hits a point where we have closest approach. You see here that this is now 4 kilometers closest approach. So this is actually already pretty good, but we can probably make it better. Let's warp time forward a little bit so that my current position is not in the way. Alright, so we would have a closest approach of about 3 kilometers now. Maybe move that a little bit around. What about this? What I want to do is I want to make my UI verbosity a little bit less so that I actually see my numbers. It's 4 kilometers here, so it's not ideal. What I can do is I can make some minor adjustments here. So my plan is actually to, yeah, you see that, to bring it down to about 1 kilometer of closest approach. So I make some adjustments here, 1.6 kilometers, 1.4. So this is actually going well. 700 meters, yeah, this is perfect. So we want to bring our closest approach to the space station in this transfer orbit down to, say, a kilometer or a bit less. Let's make it about a kilometer. So this is actually pretty great. And now all I have to do is time warp towards that point and actually have my spacecraft execute that burn to the transfer orbit to the space station. Let's do that. Alright, so this was the transfer burn, and we can see now that we are coasting up to the space station over the next half orbit, and our closest approach will be less than 1 kilometer to the space station here. So what would now happen is actually, you can see here that we still have a relative speed, relative velocity of 94 meters per second when we are closest to the station. So this is actually not what we want, because we don't want to pass the space station at that speed. We want to actually come to a stop relative to the station. So if we would do nothing now, we would actually pass the station at 94 meters per second and then start to go away from the station again, and we would stay in this elliptical transfer orbit between my circular parking orbit and the circular orbit of the space station. And we don't want to do that, so we have one more thing to do before actually concluding our rendezvous, which is we have to plan another burn at the point where we are closest to the station. So let's zoom in there and let's select a point on this orbit where we are really close to the station. Let's select a point where we will be almost as close as possible, and then at this point we plan another burn, which is of course again a circularization. So we burn prograde to cancel out the relative velocity between ourselves and the space station. So we want to bring, let me see a little bit more numbers here. We want to bring our perigee up to 400 kilometers so that we are in the same circular orbit than the station. So how do we do this? We just try to hit 400 by 400 kilometers straight, and let's see how it goes. So this is actually pretty good, because as you see here, I have brought down my relative speed between myself and the station to about 1 meter per second. So this planned burn, which I've just kind of planned here, is probably a pretty good shot. It will get us to a flight parallel to the space station, 800 meters next to it, with 1 meter per second of relative speed, so basically nothing. And this is really what we want to do. So yeah, what we can do is we can zoom to that burn and have the spacecraft execute it and see how that goes. So here we see the space station, and we can see that this burn, which is starting now, what it's doing is it's cancelling out all relative velocity between ourselves and the space station. And there we are. And this is basically the entire secret of how to rendezvous, because now, as we can see here, we are in the same orbit as the space station, and we are also we have no relative speed towards each other. So we would be slowly drifting apart because we are not in the exact same orbit. So after maybe 15 minutes we would be 2 kilometers apart. After half an hour we would be 6 kilometers apart or so, but it's still not critical. We have a lot of time now to actually close in on the space station. So this is where our rendezvous turns into the actual docking. This is what we want to do next. You can also see here, this is where we come from. This is our parking orbit down below. This is where the second stage still is. what we can actually do is we can deorbit the second stage quickly. Let's just switch. I just selected the second stage. I switched to it. Yes, I want to take control because we don't like space debris. So let's go back. I have actually installed a little bit of a command pod in the a command chip in the second stage. So what I can do is I can actually take control. I can align it retrograde. I can fire it up, and then what you can see in the map is that the orbit actually decreases again, and the second stage will hit the planet and will actually burn up during re-entry. So this is good. So now that we've done this, why not go back to our original craft? This is just some housekeeping work basically, because I like to have my orbits as clean as possible and only have my actually active spacecraft in orbit, and everything else we should deorbit. Alright, so here we are flying next to the space station in our spacecraft, and we want to dock with it. So how do we do this? We can select the space station, just click it, select it, and mark it as a target. This is how we do it. And then you can see here that in the maneuvering sphere, a blue element pops up, and we can click the blue element, and our spacecraft will happily go ahead and align itself so that it points towards the space station. And what we can do is we can now align ourselves so that the black one, which we have marked, the black side of the spacecraft is actually up and the green side is down, and that helps a lot because now I can use the ASDW keys for going forward, backwards, left, right, and the E and Q keys are up and down. So right now what I do is I want to press Q a little bit to go. Oops, okay, I kind of screwed up because we are in rotational mode now. What we first have to do, if we don't want to rotate but we want to actually translate, is we want to press the T key. So now the translation mode is enabled, and if now I press Q, then I go down. If I press E, I go up. If I press D, I go to the right. If I press A, to the left. W is to the front, and S is to the back. I'm not really sure how it works on mobile, but probably very similar. The RCS thrusters are a great way to have some small and nice adjustments to the orbit, very fine adjustments, very low thrust in all directions, and not only in one direction, because this engine here is also it's pretty good, of course, but it can only propel us forward into the direction we are pointing, whereas the RCS thrusters can propel us very slightly and very smoothly into any direction we want, forward, backward, left, right, and that's what we need for docking. So what you can see here is if we press W, we accelerate towards the station, but if we would just accelerate towards it, we would miss it, because as you can see, the space station is slowly drifting away towards the right. So we actually also want to correct and go to the right a little bit to cancel out all relative velocity between us and the station. And we have to regularly do this in many steps, because of course we are both in circular orbits, so we are going to drift apart again as soon as we stop correcting. So right now you can see that the space station is drifting downwards a little bit, so I want to press the Q key to actually also propel myself a little bit down, a little bit more. And we're still moving in pretty slowly, so I can actually press W to speed up towards the station a little bit. But then again, of course, I have to apply some sideways corrections probably. Let's just observe how the station moves relative to us. And we can see that the space station is starting to move towards the left, so I also have to move a little bit to the left. And we just make these fine adjustments. Just look at the view of the space station, of the marking, and look in which direction it drifts. And if it drifts up, right now it's drifting upwards a little bit, I press the E key to also move up a little bit. So that's how you do it. You actually just keep your space station or your target in the center, and if it drifts to some direction, you just propel yourself using the RCS into the same direction where it drifts, in order to cancel out all relative motion except going straight towards it. So we're closing in nicely, having only 400 meters left. You don't want to do this too quickly. I'm actually doing it pretty aggressively right now because I've done it a couple of times, but when you do it first, just go really like step by step, meter by meter basically. Take your time, have some patience to do that, because that's actually a very critical step here to smoothly approach your target. Alright, so now of course when we're closing in into the station, at some point we have to select where do we actually want to dock. So I'm moving myself deliberately to the left a little bit now, in order to see the station a little bit better and select a docking port where we actually want to close in. This requires some practice to actually be able to smoothly maneuver around another object, but it's working pretty well if you practice it a little bit. So here we can see that there's already two vehicles docked to the station, but there's one docking port which is actually available here, and it's this gray one here. So why don't we just select this and select this as our specific target, and now it's not going to point into the middle of the space station, but it's going to point towards the actual docking port. I think I have to re-lock the target. Now I have, and now I have to point towards the space station again. We are drifting away, so I correct a little bit to the right and also a little bit up. I can align myself so that I orient my black one up again and my green one points down, so my keys align. So now I want to orient myself right in front of that docking port and use the W key to actually accelerate a little bit towards it again, only very smoothly. This final approach phase is very, very gentle, so take your time here, be very patient. And it's the same trick again. The station seems to be drifting downwards relative to us, so we have to press the Q key to also propel us down, and this stops the relative motion. So we want to cancel out all relative motion we have between us and the station at all times, except closing in, except going a little bit closer. So 25 meters. I'm actually pressing the S key now slightly to slow down a little bit because I want to take my time. I don't want to close in too aggressively, but this is really looking very good, very smooth. It's 15 more meters. If we look at that from the side, this is what it looks like. But I want to look at it from the back because that's where I have most of the overview over the controls. 10 more meters. I'm pressing S to slow down a little bit more even. So the trick is, once your docking ports are very close together, they will exert some magnetic force onto each other to actually pull the space station towards, pull the spacecraft towards the station. So that helps a bit. So we want to smoothly approach until that magnetic force actually starts to happen, and we can see that right now. You can also see in the flight view here that a docking window has popped up, and you can actually see that it's still at 0% because we are not touching yet. But right now the magnetic force has pulled us in, and this percentage here is supposed to count up now, and that's what it is. You have to remain at zero relative motion between the two vehicles for quite some time until the docking actually is finished. But you see that the percent here are counting up, and this is a pretty good sign. We just want to be patient. If your spacecraft is wiggling around a little bit, then you can try to use the RCS thrusters to actually dampen out that relative motion, so that the docking goes a little bit better. Just be patient otherwise. It's 80% now, so that's looking pretty good. Yeah, and now we are docked. This is it. There's our vehicle docked to the space station. So yeah, a cool thing to conclude this with is maybe if we look at the propellant tanks here, we can see that we have used up 20% of our monopropellant by the RCS thrusters, and the space station has plenty of that on board. So what we could do is we could actually refuel our spacecraft on the station. So we can select the tank in question, and we say fill this tank during fuel transfer, and then we can select a full tank on the station. For example, let's say this one. This has plenty of monopropellant, like 68 tons, and we can actually say drain this tank, and you see what happens is that our spacecraft is refueled. We can just select that and then be happy with it. Alright, that's it. I hope you found this tutorial a bit helpful, and I hope that you can go ahead and practice a little bit. You have to probably try a couple of times. You have to really be patient with it, because this is nothing that works out on the first attempt. But yeah, good luck with that. And yeah, maybe if you have some questions or comments, just yeah, leave a comment under this video if you want. Otherwise, have fun playing the game. See you then.